And that's what we're going to do today. Today we're going to continue talking about covalent bonding, because remember that we were covering single bonding or sigma 1, and then we were covering double bonding. Can remember, any multiple bonding is going to be composed of one sigma bond and the rest they're going to be pi bonds. So today we're going to cover triple bonding, and then I'm going to show you how to name and write chemical formula for covalent compounds. If we're going to start with that example that we have over here. Okay, when are you going to have a triple bond? When 3 pairs of electrons are shared. For example, let's say that we're talking about nitrogen. And remember when we were covering the periodic table that we were talking about the chemical property of metals and nonmetals. Nonmetals, they are so reactive, well, not so reactive. They are able to react with nonmetals and with metals. And you have a case over here. They're not reacting, but they're sharing. See, sharing to form. In this case, you have the same element. They are sharing 3 pairs of electrons in order to become more stable. It want more stable because remember, in order to reach chemical stability, elements, they need to reach a electron in the last level of energy. In this case, nitrogen is sharing, one atom of nitrogen is sharing 3 pairs of electrons, 1, 2, and 3, just to fulfill the octet rule. In this case, you have a triple bond in there because 3 pairs of electrons are shared. One of the bonds is a sigma 1 and the other 2 they are pi. Okay? Do you have a compound over here? You don't have a compound. You have a diatomic molecule, and you write that with that subscript. Okay? It's a molecule made of 2 atoms of the same element. Since you have, okay, 2 atoms of the same elements with the same electronegativity, the difference in electronegativity is going to be equal to 0. So every time that you have a diatomic molecules, those molecules, they are non-polar because they are sharing the electrons equally. Okay, they are pulling, see, the electrons towards the center of the nucleus with the same force. Okay, so 78% of the air is made of nitrogen in this form. And that's why the nitrogen is not reacting. The nitrogen that we have in the air is not reacting with the different metals that we have here in the classroom. Okay, questions about that? Miramos, only diatomic elements or diatomic molecules are going to be formed through the bonding of 3 pairs of electrons? No. You have an example here. Okay, nitrogen has 3 electrons available for bonding. So does phosphorus. Okay, it doesn't matter in between parentheses because between nitrogen and phosphorus, remember, you're going down a group. Who's the one that has less electronegativity? The one that is all the way down. Okay, by the way, when you look at the halogen, fluorine is the one with the highest electronegativity. But since you have 1 atom of each one, it doesn't matter how you put that over here in your Lewis structure because, see, no one is in the center. Okay, so one more time, let me draw that over here. You are sharing, or they are sharing 1, 2, 3 pairs of electrons. One is a sigma bond, the other 2 pi bond. Which one is sigma, which one is pi? It doesn't matter because you're not going to be doing that on the test. Now, since you have 1 atom of nitrogen and 1 atom of phosphorus, this is the chemical formula. And be careful, the formula is not PN. It's not. That's wrong. And why is that wrong? Because the first symbol that you're going to put in your formula is the symbol of the element with less electronegativity. The symbol of the element with less electronegativity. Okay, by the way, I think that I make a mistake. It's no PN. It's no MP. I mean, less electronegativity. See? I make a mistake over here. So I'm erasing that. I'm erasing that over here. The formula, always, you are gonna put the one with the smallest electronegativity first. How are you gonna name that? When you are naming covalent compounds, we're gonna use prefixes. See, if you look over here at the subscript, when you don't have a subscript, you have one atom in there for the first element that is represented in the formula. If you have one atom of the first element, you don't have to put mono. So you're gonna start with phosphorus. But if you have one atom of the second element involved in the formula, then you have to use mono for the second one. Mono, one atom, you're gonna use mono. Nitrogen is gonna become, see, nitride. So you drop the ending of the element's name and then you add ID. And I'm making this up, okay, just to show you samples. Now, when you're naming covalent compound, it's super easy. You don't have to worry about the oxidation number because you're gonna be using, okay, prefixes. You don't have to worry about if you have a transition metal or you have a representative metal. All the covalent compounds, they're gonna be named the same way. Okay, let me see. Super easy because now you don't have transition or representative metals. And you're gonna follow the same strategy just to name every covalent compound that you have. And remember that covalent compounds, they're gonna be made of two non-metals. They're gonna be sharing electrons. Okay, so for example, look at the sample that you have over here. You have one atom of carbon, but carbon is the first element that is in that formula. Do you have to put mono? No, carbon, just like that. Now you have two atoms of oxygen. What is the prefix that you're gonna use for two? Di. Now carbon, dioxygen. You're gonna drop the ending and then you're gonna add IDE, oxide. And that's how you name them. See that? Easy piece of cake. Easy piece of cake. The second one, you have to look at the subscript to know how many atoms are involved. You have one atom of nitrogen, but it's the first one. Do you have to put mono nitrogen? No, nitrogen. Then you're gonna look at the second atom and you have 1, 2. Do you have to put mono for one? Yes, mono. Okay, oxygen becomes oxide. And you have that over there. The third one, and I made this up, I don't know if this compound exists. I'm gonna look at the first atom, but instead of having one, I have 7. The prefix for 7, phosphorus. So when I have more than one atom of the first element that is in my formula, I have to put the prefix in there. Now, look over here. 10. What is the prefix for 10? Deca. Oxygen. Okay. In this case, I'm gonna drop this over here. Decoxide. ID. Questions about that? No? Okay. Carbon, only one. Tetra, I have 4. Okay. Iodine. Questions about that? No? Okay. Now, given the name, how are you going to write the chemical formula? Ms. Ramos, do we have to worry about the oxidation number? The answer is no, because the name is giving you the subscript that you're going to use. Okay, for example, look at the first example that you have over here. Carbon tetrachloride. Carbon tetrachloride. If you don't have any prefix here, that means you have only one. Okay, the second one, chloride, comes from chlorine. And what is the prefix that you're using? 4. And that's the chemical formula for your covalent compound. Dihydrogen. So D for 2. So I have 2 hydrogen. Sulfide comes from sulfur. Monosulfide means 1. Miramos, but this is an acid. No, because you have to put that over here. See, it's no name in the same way. H2S aqueous hydrosulfuric acid. See that? You're going to have this on your test, all of them together. The hydrogen monosulfide, the state of matter is a gas, gaseous, okay? And that is a covalent compound. The phosphorus, okay, 2 phosphorus I have in there. Oxide comes from oxygen, 3 over here, 3. Sulfur, I don't have anything in there, that means that I have 1. Bromide, 2 of them. There you go. Questions about that? No, you don't have any questions about that. Halogens, 7 valence electrons. When halogens, they are forming diatomic molecules, they are sharing only 1 pair of electrons. That's a sigma bond. See that? This is a Lewis structure for a fluorine diatomic molecule. Is that a compound? No. It's still the element, but in a more stable form. So it's gonna be difficult for this diatomic molecule to react, okay? Because it has reached the octet rule. Oxygen with 6 electrons, okay? So when oxygen is forming, a diatomic molecule is sharing 2 pairs of electrons. 2 pairs. Yeah, this is not for 2 pairs of electrons. One is a sigma, the other one is a pi. And you have over here a double bond. And then you have the case, que by the way, it's only nitrogen because phosphorus is now forming diatomic molecules. And then you have nitrogen sharing 3 pairs of electrons, okay, to form a diatomic molecule. Remember that over here, you don't have compounds. No, you have elements forming diatomic molecules which are more stable. More stable. Okay? Questions about that? So if you have elements that have only one electron to share, there's a high probability that it's going to be forming a single bond. If you have electrons that have 2 electrons to share, high probability that they're going to form double bonds. Okay? And if you have elements that have 3 pairs of electrons to share, then it's a high probability that they form a triple bond. Miramos. Okay. Is it possible that they can form a bond in which 4 pairs of electrons are shared? No. Because the only non-metal with that ability is carbon. and carbon doesn't form diatomic molecules. Now, it's possible that you have a triple bond with 2 carbon atoms. Yes. 1, 2, 3. Then you have one over here with hydrogen, another here with hydrogen. But when you have hydrogen and carbon involved, you have an organic compound. And in this course, you're not going to learn about organic chemistry, especially because now we are in the pandemic, okay? This is a triple bond between 2 carbon atoms, and this is an alkene, see? Because it's alkane, alkene, alkyne. Alkene, alkane, let me see. Alkane, single. Alkene, double. Single, double. Alkyne, triple bond. If we name this element in a different way, okay? In a different way. But we're not going to touch that here. Questions about this? No?